ratio thing where I gave you a coordinate, and then you always have to solve for r to get the other trig ratios, correct? So I gave you an x and a y, and you have to solve for r. And then I put the sticky note on your thing. And so then we always have to solve for r. The difference with being given a trig ratio is you might be given y and r, you might be given x and r, you might be given x and y, you might be choking. You okay? He survived. Phone's away. I'm touch and go for a second there. Oh, still. All right. So I'm going to give you a trig ratio, and then I have to give you a quadrant. That's how you spot these. Paying attention? You spot these by I give you a trig ratio, and then I give you a quadrant. Because why do I have to give you a quadrant? Because you're solving for either x or y, and they can be plus or minus, correct? Whenever you take the square root. And so I have to give you a quadrant to limit it to either positive or negative. Okay? So, we're doing tan theta. Tan is what?
Tan over cos, or y over x.
Y over x. It's texture x. So, is this any different? I know, thank you.
The thing that you're going to there was no hesitation.
I know, thank you. I actually, there was in my head first. I had to work through a little bit, but then it, yeah. I have to admit it. That's the truth. All right. So, if I give you a tan ratio, is that any different than if I give you a coordinate? No, I'm still giving you an x and a y. We agree? So, we have an x and a y, and it happens to be 5 and 4. Okay? So we can draw our diagram if we want. We know it's in quadrant 1, so we know we're going to have an x like that. I mean, a triangle like that. We know x is 5. We know y is 4. We need to find r, and r is always what? Starts with a P. Rhymes with positive. Positive. I think I did the same thing yesterday. That's it's sticking. Okay. So r is always positive. So we have to find the third side. So we're going to do r squared equals 5 squared plus 4 squared. R squared equals 25 plus 16. R squared equals 41. And then I take the square root and I put plus or minus to prove a point, but it has to be positive root 41. Now, if I can reduce the radical, I do. But can I reduce 41? No, it's a prime number. The only factors of it are 1 and 41, so it's not going to happen. So we have our three sides. We have x equals 5, we have y equals 4, and we have r equals root 41. And now, no matter what trig ratio I ask you for, you should be able to give it to me. So cos is cook extra rice. So we're going to get 5 over root 41. And then what are we going to multiply by? To rationalize the denominator. Yeah. So I'm going to get 5 root 41 over root 41. And cosecant goes with sine, correct? Cosecant and sine. So it's sine your resume. Yeah. Oh, yeah, that's a typo. Righto, not a typo. That's my hand. Okay, good call. Okay. That is the truth, Ellen. I support that statement. Okay, cosecant, it goes with sine, and sine is your resume. So cosecant is resume your. So I'm going to get root 41 over 4. And then I'm done. I don't have to do anything to that one because it doesn't have the radical in the denominator. And then sine is your resume. So I'm going to get 4 over root 41, which I'm not done. I have to rationalize. Square root 41, square root 41. And I get 4 root 41 over 41. Number 2 shows a different way I can show it. I can give you a trig ratio. Sine your resume. So what am I missing this time? X. And then I can give you the quadrant by giving you actually the degrees that it is restricted to. So where's 90 to 180? It's in quadrant 2. So I go to sketch it. It doesn't have to be accurate, but I know I have a triangle in this quadrant. I know I have y equals 3. I know I have r equals root 10. How am I going to get x?
Root 10 squared minus 3 squared, and then square
And
the
then-
whole shebang, and you get 1.
Sure. So, we have to watch so we don't get 1. We're going to get negative. Remember, you have to draw it so that you know if it's plus or minus, correct? If it's in quadrant 2, our x's are going to be negative. The people who draw these get them 100% right. The people who don't draw them get them about 50% right, because people will miss the sign. And the option to positive 1 will be there, so you're going to get it wrong. Okay, so we're going to go x squared equals r squared minus y squared. X squared equals root 10 squared, which just cancels the square root, and 3 squared. So x squared equals 10 minus 9. X squared equals 1. And then when I take the square root, I get plus or minus. So x equals negative 1. Then we need all the trig ratios. So tan, is tan your x box or texture x? See, I just found fast where I was. And so it's going to be 3 over negative 1, which is just negative 3. Cosecant goes with sine your resume. So this is actually going to be resume your. So we're going to get root 10 over 3, which makes sense because it's just this one flipped. And then cos is cook extra rice. So I'm going to get negative 1 over root 10, and then I have to rationalize it. I'll put root 10, and I get negative root 10 over 10. Then we're going to flip over. Okay, this is the hardest way they can ask it, but it's not hard. It's just that you have to remember how the heck to do it. So I gave you quadrant 1. That was pretty easy. I told you it was between 90 and 180. I told you quadrant 2, just a little bit harder, right? This one, they just are giving us a trig ratio followed by telling us that tan has to be greater than 0. If tan has to be greater than 0, they're saying tan has to be positive. Now, them telling me this gives me enough information to figure out what quadrant I have to be in. Why? Well, let's watch. So it's sine your resume. Which one of these has to have the minus sign? The 2 or the 3? The y. So the 2 does, right? And then I cross off. Because r always has to be positive. So even if your r on the bottom was negative 3, I would take that negative sign and put it up with the y. Because r can't be negative. Okay? Now, you're right, Tom. If we use cast, we can actually figure out what quadrant it's in. So I know from this that it's sine negative, correct? And sine is negative here and here. Then it gives me another piece of information to figure out which one of those it actually is. It says tan has to be positive. So which quadrant is it? It's going to be doubled up here, right? Not this one. So when we go draw the diagram, it's in 3. And I know x equals what? Negative something, correct? Because it's over in this quadrant. Y equals negative 2, and r equals 3. So you need to draw them so that you get the right sign. Because you're going to get plus or minus when you do Pythagorean. So I want you to try 3 and 4. Try them out. We're going to have x squared equals r squared minus y squared. X squared equals 9 minus 4. X squared equals 5. Square root plus or minus, and in this case it's negative. Now remember, if you can reduce the radical, you must reduce the radical. It's not an option. If you're like, maybe I don't need to, you do. It will never go for full marks if you don't reduce your radical. Root 5 doesn't have anything to reduce, so we're okay. So x is negative root 5. So cos is cooked extra rice. So we're going to get negative root 5 over 3. Cosecant goes with sine, which is sine your resume, so this is resume your. So we're going to get 3 over negative 2. And then cotan, tan is tan texture x. See, I'm trying. So this is x your. So we're going to get negative root 5 over negative 2, which is root 5 over 2. Why is it positive? It's tangent, because it's in the third quadrant, because two negatives make a positive, right? So they should make sense. Okay, this one is cos negative, so cos is negative here and here, because it's cos and then negative, and then this is tan negative, because it's less than 0. Well, tan is negative here of one of those two arms, so it's not this one, so it just says quadrant 2 without saying quadrant 2. So I draw a triangle in quadrant 2. This is extra rice, so it's a negative 5, 13, and then my y is going to be positive because I drew it, so I know it's going to be positive. So I'm going to get y squared equals r squared minus x squared. Y squared equals 169 minus 25. Y squared equals 144. And then y equals plus or minus root 144, and in this case it's positive 12. So sign your resume. So we're going to get 12 over 13. Secant cooked extra rice, so it's rice extra. So it's going to be 13 over 5, negative 5. And then tan is your x box. And so it's going to be 12 over negative 5. Okay, I'm going to give you something to work on, and then we're going to work on solving after this. Because I wanted to do the two lessons together so you can see. I give you a trig ratio, I ask for trig ratios. I give you a trig ratio, I ask you to solve. They look the same questions, totally different. Okay, so I'm going to get you to work on these ones. For now, you're going to work on, it is somewhere on this page. It's page 202. Number 12. Just 4 questions. Page 202, number 12. 4 questions. I'll give you till 105. We're moving on. The last one you can spot because I will give you a trig ratio and then a quadrant, or a trig ratio and a restricted domain, or a trig ratio and like sine is less than 0 or cos is greater than 0 or whatever, right? These ones will say solve. Solve means doesn't matter what curriculum you're in, it doesn't matter what math class you're in, it doesn't matter where this falls in life. If it says solve in math, in the end you should have whatever the variable is equals a number of some sort, or a few numbers, box it, answer. Right? So whenever it says solve, it doesn't matter what math curriculum we are in, we look and we see variable. So my variable is theta. So in the end, I better have theta equals at least one number, box it. Or I could have no solution if they didn't work out, right? Like if when we've done where we've checked and gotten extraneous roots to the whole thing, then it was no solution. But when it says solve, in the end, I should have theta equals answer, or x equals answer, or m equals answer. Whatever the variable is equals answer. That's what solve means at the end. So if you're never getting to that point, you are not solving it. You must keep going. Okay? So when we're solving a trig, we can treat this, if we want, we can treat the sign like a variable. Now this isn't going to be as intense, but when it gets to degree 2s, it is. So we can do this if we want to. We can go let m equal sine theta. Because the sine theta is the part that we don't know how to deal with, right? At this very moment. We will know in a few seconds. But so we have to do a let statement. You can't just change it to an m unless you actually say let m equal sine. You have to tell them that you're letting m equal sine, okay? So if we let m equal sine, we can go 2m equals 1. Now you go back to junior high and grade 10. How do I solve that? Divide by 2. And now I have m equals a half. And the crappy thing is, if we replace, you guys will box and be like, boom, I have an answer. There was no m in here. You put the m in. We need to have theta equals answer, correct? So after we've solved, we need to put our sine theta back in. So sine theta equals a half. Now that looks a heck of a lot like what we were just dealing with, trig ratio, right? But I have to solve. Now, if you get sine theta equals a half, root 3 over 2, or root 2 over 2, you just go to your unit circle and pull the values off. Theta is always a what? A degree or a radian for us now, right? So if I'm going theta equals, I better be putting a degree or a radian in here. How do I know which one? Well, they'll give you a restricted domain. So the restricted domain that they gave us up here was 0 to 360. So my answer needs to be in degrees because the restricted domain was in degrees, correct? And 0 to 360 is actually just the unit circle. So you go to the unit circle and you pull off all the places where sine theta equals a half. So you pull off all the degree spots where sine theta equals a half. Everyone go look on your unit circle. Okay, so sine theta equals a half at 30 and 150. You need to make sure you have a degree symbol or it is not correct. You can check these. Go to your calculator. You're going to press sine of 30. Before you press sine, you hit your hand and you say, I need to be in degree mode. You can check these. So you go sine of 30 and hope you get 0.5. Then you go sine of 150 and hope you get positive 0.5.
He's absorbing the information.
Through the paper.
Yes.
Okay. Bring your A game then. Like a whole new level of learning. Okay, flip over. And life changes. Okay. Once again, I go let m equal cotan theta. So I'm going to get 4m equals 1. Divide by 4. M equals a quarter. M just happens to be cotan. Is a quarter on our unit circle for cotan? No. Remember, cotans and tans have the option of root 3, 1, well, root 3, plus or minus root 3, plus or minus 1, plus or minus 3 root 3, zeros, and undefined. Those are the only options on the unit circle. So a quarter is not on there. So we're going to have to do the reference angle root. So I can go second cotan 1/4. Wait, no I can't. What's not on my calculator? Cotan is not on my calculator, correct? But its friend is. So cotan is x your, correct? We know we have an x, we know we have a y. So what can I actually get instead that I do have a button for? Tan. Tan theta is 4 over 1, or you're right, just 4. Can I get a reference angle for that? Yeah. That's what we're going to do. Yeah. So we have tan theta equals 4. I'm just showing this up. And then I go tan neg 1 both sides. And I'm going to get theta equals tan neg 1 of 4. Now I have to decide what mode I need to be in. What mode do I need to be in? Degree. So plug it in. And we're actually going to get reference theta. We're going to get the reference angle. We'll go to 1 decimal place. What did you say this?
You want 1 decimal place, and it's
Yeah.
75.96.
Yeah, we'll say 76 degrees. Now that's the reference angle. The reference angle can be found anywhere in those bow tie angles from the x-axis, correct? How do I figure out where I need to draw it? We know it's between 0 and 180 at the very least. And then we use, yes, we use cast. And we go here, and we have cotan is positive. This one is out, and this one is out, only due solely to the fact that that's 0 to 180, correct? So those two are gone. 0 to 180 is the top two quadrants. And I need where cotan, which is tan, friend, is positive. So where is it going to be? First quadrant 1. So I draw a terminal arm on quadrant 1, and I draw my reference angle, which happens to be 76. And what do we know about the first quadrant and the reference angle? They're the same. So my answer to this is just theta equals 76. And the reason why they'll restrict so much is because it's perfectly numeric response. One answer, right? Separate sheet of paper. Practicing homework together. We can fail together? No. Okay, solve. We're going to do this one. 2 cos theta minus root 3 equals 0. And I want it from 0 to 2 pi. So your answer needs to be in radians. You're going to try that one out. And you're going to try this one out. Secant theta plus root 2 equals 0. And I want it, I'm just going to get you to do from 0 to 2 pi, but then I'm going to show you how we restrict it to make it different. So you're going to just do those from 0 to 2 pi for now. So we go let m equal cos theta. 2m minus root 3 equals 0. 2m equals root 3. M equals root 3 over 2. So cos theta equals root 3 over 2, which is on the unit circle. Cos is positive root 3 over 2 here and here. So at 30 and 330, but it's in radians, so pi over 6 and 11 pi over 6. We agree? Okay. What if I do this? What if instead of saying 0 to 2 pi, which is what I asked you, I ask you from negative pi to pi. Now, just so you know, we just get the coterminals. So I don't care. I never look at the restricted domain other than looking at it to see if it's in radians or degrees. I never do. I used to when I first taught it. I'd be like, let's go look at the restricted. I don't anymore because that was. But see, isn't that great? I love that I can make that not happen. So I, in the last years, have adjusted my ways because that was tears and bad things. We don't want that. So whenever you're asked to solve, I always find between 0 and 2 pi or 0 and 360, no matter what the heck the domain is, I don't really care. I just look and see if it's in radians or degrees. Will you see? So had I asked for the domain like I just did, I would have still found it the exact same way I just found those. Okay? I now look at those and find the coterminals that would fit on there. Okay? So I need from negative pi to pi. First off, what the heck does that mean? That means from 0 to negative pi and then 0 to pi. We agree? Technically, you'd never write it this way because that's stupid. You'd write it from negative pi to 0, but that throws people off. Basically, let's deal with the negative pi portion first. Okay? So this is 0. We agree? And if I want to walk my way to negative pi, I would do this, counterclockwise. I mean clockwise, not counterclockwise. I would go 90, and then I would go 180, or negative pi. We agree? So if I have an arm that lands in there, I have an angle that works. Do we agree? So here's my arm. It's 11 pi over 6. I cannot use that answer, though. Why? It's too big. I can't use 11 pi over 6 because the domain I gave you is actually from 0 to pi and 0 to negative pi. Do you see that? And 11 pi over 6 is too big. It's past pi. Do you see what I'm saying? It's too big. So I go from 0 to pi over 6 to this, and then I stop. I can't give the 11 pi over 6 the way it is because it's too big. Can I give the pi over 6 as an answer, though? Does pi over 6 work? Does it fall between 0 and pi? Yes. So pi over 6 is good. So we'll go theta equals pi over 6. That's one of my actual answers that will fit in here. Then I have to go this way. I need to find the coterminal that when I start here and hit this arm, I stop. It's a really tiny angle, isn't it? What is it the same as, do you know? If this is pi over 6 and going clockwise, what's this going to be? I mean counterclockwise, what's this going to be? Just negative pi over 6. Which to the right is plus or minus pi over 6. Okay, that's my reasoning by looking at it. Now, because you hate radians, you could choose to go a different route. Your answer in the end has to be in radians, though, right? That's the be-all, end-all. So you need to be really, if you're like a person who does not like working with radians, you have to be really good at converting both ways. Converting to degrees and converting back to radians, right? We can do that. That's totally fine. Let's look here. What is negative pi in degrees?
180.
Negative 180, right? If you don't know, radians to degrees, pi on bottom, correct? RD pod. So I would go negative pi times pi on bottom. So pi on bottom, these cancel, and I would get negative 180 degrees. You see that? Okay, what if I wanted to convert pi? It'd be 180, but if we didn't know that, we could go pi, radians to degrees, pi on bottom, RD pod. So 180 over pi, the pi's cancel, and I get 180. So technically, in degree mode, my answers need to be between negative 180 and 180, which usually makes more sense to people. Okay? Now, I then would use my angles here in degrees, wouldn't I? So this one would be 30, and this one would be 330. Do we agree? 30 and 330. The blues. The blue ones that we got originally would be 30 and 330. Do we agree? My domain is from negative 180 to 180. What do I know about 30 and 330? 330 is too big, right? You can see it now. It makes more sense in degrees. Do you see that? Does 30 fit in there? Yeah, 30 is a good answer, right? So we know theta equals, it was a theta. Theta equals 30. We know that's one of the answers. Now, I have 330. It's too big. How can I find its coterminal that might be smaller than it? Minus 360. And what do I get? Negative 30. Does that fit between 0 and negative 180? Yes. Those answers make sense for most of you. Degrees work. Radians make you freak out. I'm okay that you convert. The problem is people don't know how to convert. So you have to be able to be really great at converting if you are going to be one of those people who's going to convert. Now that's lovely that those are the answers. If you give me that as the answer, you're not going to get the marks. Because why? I actually asked it in radians. So we'd have to convert back, right? So degrees to radians, pi on top. Degrees to radians, pi on top, or you can just look up your unit circle, but that's fine. So pi on top. So I go 30 divided by 180, math, enter, enter, and I get pi over 6. And then I do negative 30 times pi over 180, and I get negative pi over 6. So often they're going to say theta equals plus or minus pi over 6. You see how restricting the domain makes it a bit harder? But it's not impossible because it's just coterminals. Just coterminals. So honestly, when I get a solving with degrees, I'm way more happy for you than with radians because I know you guys find it easier. Okay, let's look at this one. So we're ultimately going to get, let m equal secant theta, m plus root 2 equals 0, m equals negative root 2. So secant theta equals negative root 2. Secant is negative root 2 over, what's it over? Every single question, every single answer is over 1. Every single number is actually a fraction, right? So secant goes with cos, so it's cook extra rice, so this is rice extra. So if I want cos theta, it's going to be negative 1 over root 2, which people think isn't on the unit circle. But remember, it is. It's just the unrationalized version of root 2 over 2. It's totally on the unit circle. Multiply by root 2, multiply by root 2, and I get negative root 2 over 2. Now where does that fall? Yeah, it's the 45-degree reference angles, and it's cos negative. Cos is negative here and here, correct? So it's x is negative here and here. So it's going to be at 135 and 225. Now, I'm working in degrees. Is that okay to work in degrees? Yes, as long as in the end you have your answer in radians. Make sense? Okay, so for the answer to this actual domain, I would say theta equals 3 pi over 4 and 5 pi over 4. That would be if I kept that domain. We agree? Okay, what if I did this domain instead? Negative pi, comma, 2 pi. And they can go square brackets. They can write their domain like this because that's still a domain. It's just an integral notation. And it means that it's equal to 2 pi and negative pi. So if negative 2 pi and negative pi and 2 pi were answers, I could list them, right? If there wasn't an equal sign or they were round brackets, I couldn't list them. So what is negative pi in degrees? Negative 180 degrees. And what is 2 pi in degrees? 360 degrees. So have my answers changed? Do either of these not fit? No, both of these fit, correct? So I'm going to still use them. Because this time I didn't stop at pi, did I? I gave you the whole thing. So those two answers still work. And I will just write them in degrees for now. So 135 fits and 225 fits. What's my problem? I keep going negative though, right? I have more. So if I ever have negative ones, all I do is I find the coterminals of these and see if they fit. That's it, right? So it's still important to find from 0 to 2 pi and then just boom, boom. Or 0 to 360, boom, boom. Take your coterminals this way, boom, boom. Take your coterminals above. Because sometimes they might go from 0 to 480 or something. And then you just find the coterminals positive. But I always find from 0 to 360. So here I'm going to check and I'm going to go plus 360. And I'm going to go 585. It's a really nice answer. But it's too big. So should I be adding to find my coterminals? No, I should be subtracting. So if I go 225 minus 360, what do I get? Negative 145. That is true. 145 is not on the unit circle. 135. Is that in my domain? Yes, because from 0 to negative 180, that fits. Okay, negative 135, that fits. Now let me check my next one. 135 minus 360 is negative 225. Does that fit? No. I go to negative 180, negative 225 is further down this line, correct? So it doesn't fit. So I have my answers, don't I? But what's my question? What do I have to still do? Convert it to radians. Degrees to radians is the easiest because you just take it divided by 180, math enter out of pi, right? The degrees to radians is fast. It's the other way that's a little more brain. So if I go 135 divided by 180, math enter, I'm going to get plus or minus 3/4, or 3 pi over 4. That's this one and this one. And then 5 pi over 4. You see where I'm pulling my solutions from? Does that make more sense? Okay. 3. What if I give you I will go 3 tan theta minus root 3 equals 0. And I want it from negative 180 square bracket to 540. Try it out. We're going to go, let m equal tan theta. 3m minus root 3 equals 0. 3m equals root 3. M equals root 3 over 3. Tan theta equals root 3 over 3. If you forget that this is a 30-degree reference angle, you can go second tan root 3 over 3, and it'll tell you it's 30. Okay? So, we need tan positive. Tan is positive where and where? 1 and 3. So this is 30. And this is 30 as well. But what's this one going to actually be? 210. Do those fit in the answers?
Yes.
Yes. So those are two solutions. And then we have to check its coterminals. So if I subtract 360 from 30, I get negative 330. Does that fit? Does that fit in my domain from negative 180 to 540? No. Let's check the next one. Plus 360. Does 390 fit in 540? Yep. If I add another 360, it's way too big, so I stop. Right? I keep adding and subtracting until I get outside the domain. This one I have 210. If I subtract 360 from it, what do I get? Negative 150. Does that fit? Yep. Then I check 210 plus 360. And we get 570. Does that fit? 570 fit? No. So here's my solution. Your homework is page 211. Number 1, and then 5A to C. We're going to do harder ones later. And by harder, I mean that we've agreed to this as well.